Hey everyone, it's Corbin, and today we are gonna be working with the Raspberry Pi. Now, if you don't have any background, things might start getting a little bit confusing from now on. So I suggest that you arm yourself with patience and watch at least videos 4, 4B, and 7 from this series. We're gonna be using concepts that are explained there, and if I explain them here again, this already long video is gonna be twice as long. Remember that the most important thing you get from these videos is knowledge. The way things are going out there, we need more and more people that are comfortable with technology. I am going to show you how to write an operating system image on an SD card, put it on the Raspberry, boot it for the first time, and get it ready to install useful services on it. Here, in Corbin's workshop. Hello everyone, we are back at my computer table, and today we are gonna start the installation of everything on the Raspberry Pi. The process is gonna be a little different this time. You cannot just connect a USB with Bentoy and work from there. We need to take the SD card to our computer and burn the system image on it. This SD card we have here. This one came with my bundle. You might need to buy one separately. Comes in this nice case. And to connect it to my computer, we're gonna be using a card reader. This also came in the bundle. It has slots for the card, and you can connect it either to USB or USB-C. Now, if you need to get one separately, I got this one here. A cheap one from the brand Ugreen. It's USB 3.0. And you can see it also has the slots, and it's also USB. Oh, this is tight. And USB-C. So I'm gonna use regular USB. And we take out the SD card carefully. Definitely not like this. And we are going to insert it. Now, I'm imagining it's gonna go like this. And it clicks. So the card is inside and it's ready to be used. I'm not gonna show it here because the USB 3.0 slots are behind my computer and that's gonna be a mess to record. But just plug it in. And don't mount the drive yet, just connect it. And I'll see you in my computer view. We're now on my PC, and we'll see how messy this is gonna get. First, we need to find the image for our operating system, which is gonna be Diet Pi. And download Raspberry Pi. Mine is the 5. And here we have download, we have the SHA as usual, and we have a signature now. Okay. So let's download the file. SHA. Oh, it's on the browser. So let's download the signature. And let's check this. Wait a minute. For the signature, we need a key that doesn't seem to be anywhere around here, right? So let's go back to the SHA. Let's now try to see if we can investigate Diet Pi, verify, download, public key. This is For apt-get, not where we're looking. Get. Okay, this is more like it. Signature of download provided, but key isn't. And it is the Diet Pie website issues. Okay. This might give us the answer. And here we have the creator himself. Yeah, so. Okay. So this is the public key. Save it. That's fine. Now we have the key. So it seems like everything is downloaded. So here we have our files. In order to do all of this, you're gonna need the program GPG, which you can get from the package GNU-PG. It's the first one. Okay, we have it. Of course, I know I have it. I'm just showing you. So GPG, import. Let's grab the key we just downloaded. And we have it now. And now we need to verify the file. So first the signature, then the file itself. And it tells us, good signature from blah blah blah. Warning, this key is not certified with a trusted signature. That sometimes happens. There's not much problem for that. What's important is that the signature matches. And this seems to be okay to me. So our download is fine. Oh, I forgot. We have to check the checksum for the file. 39F7, 39F7. Let's move this out of the way. And it's 31BD1F. It's good enough. Okay. So the file is fine. Now we need to burn this image into the... Oh wait, hold on a second. I need to extract this first. Now we have the image file. So now with the image file over there, we are going to use again the DD program that I showed you before. So I think I'm gonna need to sudo DD. Input file is gonna be our image. The output file, oh wait, before we do that, let's check our blocks. Okay, so the 64GB USB stick is SDD according to this. So that's what we're gonna use. So sudo dd, input file is gonna be the image, output file is going to be /dev/sdd. And we need a few flags. Comp fsync. And output flag is gonna be just direct. And we are gonna ask for status progress, please. So this seems okay to me. Let's get started. STD, I confirm it is the disk. Let's go. Sorry, let's do that again. I forgot to specify the block size. I am really dumb. I was wondering, it's going way too slow. So that should do, I guess. Okay, burning image into the SD card, take 2, go. See, that's a lot better. Let's see how that went. It created 2 partitions. And I'm not sure if this is gonna work, but let's try it on the Raspberry now. Well, let's see if we can make it work. Here we have our card reader. We push on the card and it will click and it will eject it. And now take it out. On the Raspberry, the card slot is beneath the card. Right here. Set it like so. This one doesn't click, but it gets firm in place. So I suppose that's where it belongs. Then we're gonna connect a screen. Move the caps. This is a micro HDMI cable. It's very tangled. Okay, micro slot is here, whichever you prefer. There it is. The other one I'm gonna connect to my capture card. Hold on. I didn't plan this properly, to be honest. See if it fits. Alright, seems to be fine. Next, we are going to connect the keyboard, which is plain USB. It has a few ports. Up here. We have a keyboard now. Here we have the internet, let's not forget it this time. It has a nice click. So now we have display, we have keyboard, and we have internet. Okay, now the display is properly connected. And finally, I suppose we connect the power cable. The power cable is USB-C. Let me turn on the display. Now, let's see if we can connect this here. It turns on immediately, so keep that in mind. Now, fingers crossed. And there it is. The Raspberry is alive. Oh, that's more like it. Okay. Oh, wait. Hold on. I didn't update the tag. Give me a second. This is the Raspberry now. And here we are. Disclaimer. I am re-recording this part a couple of months after I did originally. Originally, I made this video immediately after video 4. But I had other priorities, I had to let some time go without polishing and everything. And now, things have changed a little. So I am gonna redo this part. Change for the better, I promise. So previously, I had a completely different approach for the firewall. But as you saw in video 7, NFTables now works properly with Docker. So our setup is going to be very similar to the building. thankfully, the more unified our experience is across our devices, the better. So let's start by logging in to our device. The login is gonna be root, as you can see right there in the message at the top, and the password is dietpie. So, the first time you log into the dietpie, you are going to be prompted with some choices to make. Dietpie survey. I am not going to join a survey. Keyword layout. Going to be a US layout. Say the first. US English. Okay, so default password for these ones. I'm gonna use a temporary password and I will change it later. So and now a default password for the applications you're going to install. Some applications like databases and such use a default password. Here you can set what it's gonna be. Put whatever, you can change it later. Now, the UART is that stripe of pins that you will see very prominently on the tab and on the circuit board. That's for interfacing with other electronics. We are not going to be using that, so I am going to disable it. As it says, you can re-enable it at any time, so I'm going to disable it now. Okay, let's see. So first, SSH server. SSH is an incredibly useful tool to remotely connect to your device. We use it on the B-Link in the previous videos. Here by default it uses a light version of SSH called Dropbear. I don't have much experience with it. I don't really trust much in terms of security. I think I'm gonna change it for the well-known OpenSSH, since it's gonna be pretty much a main feature of this device. What else? This looks fine. Find software. So if you come here, it has an assistant that can let you install a myriad of software packages. It would be up to you to check what you would like from here. I will install everything manually as always for educational purposes and because I like more control over what I get. But really, you can get browsers, you can get even the Matrix client Synapse is around here somewhere that we will install later. If you want a one-click install, you can use this. And it can even have graphical desktops if you want. But for this device, it's gonna be terminal only. Like I said before, when you are setting up a server, especially with limited hardware as I am doing it on a really tight budget, you want to extract as much performance as you possibly can from your hardware. And this is just a waste of performance. So I'm gonna get out. And I am simply going to install, I guess. Yes. Make sure that your device is connected to the internet, obviously. I'm sorry for looking like that, but I am looking at my side screen uh, for the Raspberry Pi, not the one in front of me. Now that I think about it, I could have connected the Raspberry Pi to the main screen here in front of me, but I didn't think about that. I'm sorry. And there we are. So, we have the classic commands. We can use ls. Where are we? Oh, we're in /root. I would like to exit and enter with a different user. So, diet pi with my new password. There we go. That's more like it. Home diet pi. Alright. Now, if you have seen previous videos, you know that you can create different user accounts, but whatever you do, do not remove the diet pi account. I read in different forums that the assistant tools that diet pi provides you, like diet pi config and diet pi software to install stuff, rely on this account. So don't remove it, let it be. I am going to use the diet pi account. I don't consider it a risk since I will be using key pair authentication like in the billing in any case to connect. So, what are we gonna set up first? First, we need to update our packages. So, sudo apt-get update. Followed by upgrade. Remember, this distro is not Arch, so the package manager is different. It's apt-get. Well then. So let's see. Apt search Docker. Wait a second. I'm getting ahead of myself. I forgot two important things first. First, I need a text editor. I can't do anything without one. So, sudo apt-get install nvim, is it? Okay, so can I run it now? Oh, not located. Probably neobim. That's more like it. All right. So now, after this, let's go to install nftables, shall we? So let's sudo apt search nftables. And there it is. Install nftables. Is that correct? All right. So now let's configure the firewall. Let's see. And beam slash need sudo. Conf. Here we have it. It's gonna be a pain in the ass to rewrite all of this thing right now. So let's do it in a different way. Let's start our SSH server so I can finally do things from my main computer. This is driving me crazy. So sudo systemctl enable. Oh, let's see. Status SSH daemon. It's active and enabled, so we don't have to worry. Let's move to the personal computer and see if we can get into it. Hold on, before we do that. CPU. Doesn't give me my IP address here. Let's see like this. There it is. It's 75. Alright. Now, let's finally move. Desktop. Come right here. Open a terminal. And let's see my SSH command. The one I use for the billing. But this one is gonna be for now default port. I haven't changed anything. 5 and the user is dietpy. Yes, please. Password. Oh, thank God. Alright, so I don't have to look at the other computer anymore. I will keep it as a backup, but now I can look straight ahead and I can use my own keyboard. That's gonna make things a lot easier. Alright, so let's configure the firewall now. Sudo nvim /etc/nftables. We're going to get rid of this. And here in my other tab, I have the file that I copied from the billing. It's exactly the same. There we go. We have it. Now we are not going to have hightail on this one, so I'm going to delete this. And the port is the default port. So let's use 22. I think we can use SSH as well. And this should do it. Now, the file is changed. Sudo nft. Please rule set. And have. So we are gonna flush it anyways. And we are gonna load the new file. /etc/nftables. List it. Okay, apparently it is working now. Hey, Corbin from the near future here. I was forgetting something really important here. The firewall is set and it is already working. But we need to start the service, enable the service, sorry, so that the configuration will be loaded every time you start your device. Otherwise, when you restart, the firewall is going to reset. So we are going to check system ctl status nftables, and you can see that it's disabled. So we need to enable it. Enable and check that it is in fact enabled without errors. That's fine. That's enough. Now we are ready to keep going. The firewall should be ready and it is accepting our SSH connection, or we would be dropped by now. Let's confirm by connecting again. Seems good to me. Now, the firewall is ready, according to me. So now let's go to setup Docker. Now we are going to do this thing, the apt search Docker. You can see immediately how I type a lot better now. And we agreed that it seemed like the packages were pretty old. So we are gonna be following the Debian instructions for installing Docker. I'm going to add the Docker repository to see if we can get please more updated packages. So we already did the update. We're going to try to install this thing. Okay, nothing to do. Already newest version and newest version, correct. Now we are going to do this. So that's the beauty here. You can copy and paste the commands. This one is going to get the Docker key for the keyring. And we're going to change the execution permissions for it. Now we are going to do this. We're going to append to the sources list, the Docker sources, some stuff. And we are going to keep copying all of this thing. Lastly, eoff. This should end the process. There we go. And now let's run update again and see if we get more updated versions. All right. So now apt search Docker, please. Come on. Give me better versions. Where is it? No, it's 26 anyways. Oh. Let me check for a little bit to see if I can solve this. And never mind. I was a little confused. Like I said, I am not used to Debian packages. What's happening is that let's search for Docker again. You will see that I was looking at Docker CLI, for example, that is 26, but the community edition is 29. So this will be good enough for my purposes, because we need Docker at least 29 so that it can play nice with NF tables as a firewall. Okay, so we are not gonna have a problem at all, I hope. So we are going to continue. You can use apt list to check all the different versions, that's fine. So we are going to copy the command to install the packages, the latest. Okay, that should be it. Okay, and we're going to check if it's running. Yes, please. right. So it's done. Allegedly should be running. So let's see. Systemctl status Docker. It's active and enabled. Seems to be fine. Oh, right then. Alright. I just restarted the system. And in case you're wondering how, it's a little different than in Arch. I did sudo systemctl reboot. This is the command. Now, let's check if Docker is running correctly. I think it needs sudo. Alright. So we get a warning around here that says that git source cannot be enabled. I suppose this is for updating because we don't have git. So we should try to install git. Sudo apt search git. Let's see. Oh, there's a lot of git packages. Git. That's the only one we need. Git. I don't think we have git source, do we? No. Okay. So just git. Sudo apt install git. Okay. The next thing we need is configure Docker like we did on the B-Link to improve the log usage and to enable the compatibility with NF tables. So for that we need sudo nbeam /etc/docker/daemon.json. Alright. And here we did do exactly the same we did. Put this, we copy. We're going to add a comma here to add another setting, which is from Docker with NF tables. We know that it's this setting here. And that's it. That's all the Docker configuration. So now with git installed and this configuration modified, we are going to stop the Docker service. And let's stop the socket as well, just in case. And let's start it again. Let's see now the status. We don't have a warning about git anymore. That's solved. But let's check if our firewall, if our NF tables have the Docker additions. So sudo nf tables, sudo nft list rule set. And that looks like a lot of Docker stuff to me. Let's see. Rerouting. But it seems to me that my stuff is not there anymore. So let's make sure. Let's flush the rule set. Hold on. For that, let's stop Docker again. Socket. Let's flush the rule set. let's load our file, which is in /etc/nftables. Let's check that it was loaded properly. Was. And now let's start Docker. So start Docker. Let's check the rule set again. Okay, now we have our rules and we have the Docker rules. Perfect, now it's working perfectly. All right, so what's next? Oh, the group. I needed to add my user to the Docker group so I don't have to run Docker stuff with sudo. So for that, it was sudo user mod append group docker for user dietpy. I think that's it. Let's exit. Let's connect again. Let's check groups dietpy. Okay, I'm in the group dietpy and docker. So that should be enough. Now let's try to run the basic image. Docker run, I think it was called hello world. There it is. The firewall is working, Docker is working. That's pretty much all we need to work. I think this is it. The Raspberry is ready to work. Whew. Oh, wait. We can add the key pair authentication already. Let's finish configuring SSH before we finish the video. So we're gonna exit here. So the command is ssh-copy ID input is .sh/lambda poop, and the target is dietpy at 192, 168, 175. Password for dietpy. One key added. So if I now try to log back in, it's direct. If you have any doubts about the process of key pair authentication, there is a dedicated video in this series, video 4B. And that's it for that. We need now to finish configuring SSH. So sudo nvim /etc/ssh/sshd.config. We don't have a file, huh? Let's see. I see SSH there. So what did I do wrong? SSH/SSHD. All right, here we are. So the port, remember, you can change it to something custom, depends on you. I am going to change it to a different one. Now let's use port 15,000. I will of course change it later. So what else? Authentication. Permit root login. Hold on. Let's just copy this for reference, and we are going to see permit root login no. Prove key authentication. Yes. And I think that here it was permit password login no. Alright, it's password authentication. So, password authentication, no. And that should be it. No, wait. So, no root login. Password authentication, no. Public, yes. Something else. I think that's gonna be it for now. Alright. So let's see if I can still log in. Sure, fine. Okay. This is gonna be the initial configuration for the Raspberry Pi. On the next video, we are going to install the first useful thing into this thing. We are going to install a DNS server. Hey, this is Corbin from the future. I want to do a few more things before I close the video. Number one, I want to talk about the temperature. Right now it's a little cooler, but you could see earlier that it was getting pretty high and it has a warning on temperature. There is not much I can do because I live in a rather warm place. However, before the madness with hardware started happening, I managed to secure some upgrades. I got a Raspberry Pi with 8 GB of RAM, I got a case with heat dissipation and a fan, and I got an SSD with 1 TB of space. And later on, soon, I will have a video performing surgery to show you how to transfer pretty much what we have done in this Raspberry Pi to the other Pi and install all of these upgrades. And hopefully that will be able to keep the temperature more in check. We will see about that. But so far, I am very, very positive because things have gone really well. The second thing I want to do is I want to run htop and show you the performance. Now, at this point in time, I have already the firewall going, the Docker engine, I have the DNS resolver, and I have Pi-hole as well. And we can see that everything is running on only 269 megabytes of RAM tops. That's pretty light, I would say. So this gives you an idea that how low you can go with hardware and still get useful things. Especially important now that we are undergoing a hardware crisis. But yeah, so far I really like Diet Pi. Let's hope that we don't find any problems with it in the future. And that's pretty much it on performance. The other thing I wanted to tell you is how to reboot and shut down your Raspberry Pi. It's not like in Arch. Here we do it using systemctl. So you do something like sudo systemctl reboot to restart, or no, hold on, or power off to turn it off. However, there is an observation. This works well if you are directly connected. But right now I am using SSH. If I reboot or power off the device, my SSH session is gonna freeze and my terminal is gonna be unusable. I don't know why with the billing this doesn't happen. Maybe it's the version of OpenSSH because the repos for this distribution use older versions. I'm not so sure. But the way you can get around this is by writing your command, like reboot for example, space ampersand and exit. Ampersand makes it so that your first command is going to be run in the background and immediately the second one will execute. So this should reboot the device and get us out of the SSH session. Let's try it. And there it is. And the device should be rebooting. See, I cannot connect again until it's done. any second now. There it is. See? So that's the key. Ampersand and exit. And that way you can safely close your SSH connection and you don't screw up your terminal. And that's it, guys. Thanks for watching and see you in the next video.